In these next two examples, we're going to be solving systems of equations. When we solve a system of equations, really what we're doing is we're finding the point in xy that's going to make both equations true. So we want to find a point that we could plug in the first equation and it would make this true, and we could also plug the same point into this equation, it would make it true. So these first two examples ask us to solve by elimination. This is also called addition sometimes. In order to do this, we want to get either both x terms or both y terms to have opposite coefficients. When I mean opposite, if one was 3, we would want the other one to be -3. If one was 7, we would want the other to be -7. And we can do that in a few different ways. So I'm doing it one way, it could be done different ways. So what I'm going to do is I'm going to work with the x values. So working with the x values, I want to find a common factor, a common multiple of 10 and 2. Well, I can change this to be a 10 by multiplying by 5, but I don't want a 10 because I already have a 10 here. I want -10. So what I'm going to do is I'm going to multiply both sides by -5. I'm multiplying by -5, so I get opposite coefficients for my x value. So I have to distribute here. So this would be -10x plus 5y equals -5. And then I'm going to keep this bottom equation the same. And then what I'm going to do is I'm going to add. So I'm going to add one equation to the other. This is why sometimes it's called addition. And we get -10x plus 10x is 0. And that's what we want. We don't want the x value anymore, and that's why it's called elimination sometimes, because we just eliminated the x's. 5y minus 4y is simply y. And then -5 plus 0 is -5. So we just found the y value is -5. We're going to go ahead and use this -5 and put it back into either one of the original equations. So let's just take the first equation, and we're going to do that to find x. So we have 2x minus y equals 1. That's our original first equation. And I know now that y is -5, so I can put 2x minus y, well, y was -5, equals 1. So we have 2x minus a negative is a positive. We'll subtract 5 from both sides. And we get 2x equals -4. Dividing by 2, you get x equals -2. So x is -2. When you solve a system of equations, you need to put it as a point. If you think of this graphically, you're really finding the point where two lines intersect. And so our x value is -2, our y value is -5. So our answer is -2, -5. It would make both of these equations true. You can always go back and check it. So I'm going to go ahead and check this one. And we're going to check it by plugging it into each of the equations and seeing if it makes the equation true. So we have our first one, which is 2 times x, where we're saying that x is -2, minus y, which we're saying y is -5, we found that, equals 1. Is that true? 2 times -2 is -4, minus -5 is just plus 5, equals 1. -4 plus 5 is 1, and that's true, so the first one works. Let's check the second one. 10 times x, which we see is -2, minus 4 times y, which y is -5, equals 0. This is -20 plus 20 equals 0, and 0 does in fact equal 0. So my answer is correct, -2, -5. We're going to go ahead and erase some of this so we have some room for our second equation. Okay, second equation. Let's go ahead and eliminate the y's here. Probably not what I would normally do, but I just want to show you something that we can do here. So to eliminate the y's, here this is a 4y, and this is a negative 5y. So they're already opposite signs, which is good, but we want them to be the opposite number. So we think, well, what does 4 go into that 5 also goes into? 20 is the smallest one that works. So we want to get both of these to have a 20. So we want a 20 here, and we'll want a negative 20 here. To do that, to get 4 to be a 20, we have to multiply by 5, because 5 times 4 is 20. And to get this negative 5 to be a negative 20, we have to multiply by 4. And we could do both. Multiply by a positive 4 because we already have the negative here. So taking this first equation, the one that has some blue, distributing, I'm going to get 20x plus 20y equals negative 80. The other equation, the one in red, I would get negative 8x minus 20y equals 116. And now we can use elimination. Or we can add them together and they'll eliminate. 20x minus 8x is 12x. 20y minus 20y, that just becomes 0. Negative 80 and 116 is 36. If you subtract those, you get 36. And now we can divide by 12, and we get x is 3. Now we can take that x equals 3 and plug it back into either one of the original equations. I'm going to choose the top one because it has the positives. So let's go ahead. We have our x equals 3. So I'm going to take this top equation, the one with the 4's in it. So we have 4 times x, which we solved for, and we got 3, plus 4y equals negative 16. This is 12 plus 4y equals negative 16. We can subtract 12 from both sides. 4y equals negative 28. Dividing by 4, we get y equals negative 7. And remember, we want to write our answer as an ordered pair. We put the x value first and the y value second. So 3, negative 7. Again, we could check. We could plug that into both of the originals and make sure it works. So that was solving by elimination or addition. We also learned to solve by substitution. Solving by substitution works best if one of your variables, so you have 4 variables here. You have your first x and your first y, your second x and your second y. If one of your variables has a coefficient of 1 or negative 1, is a good time you can use substitution. So notice here that this one has a coefficient of 1. And so since that one has a coefficient of 1, what we can do is we can take that equation and we can solve for y. So we're going to take this, negative 4x plus y equals 12, and we can easily solve for y by just adding 4x to both sides. So y equals 12 plus 4x. This is called substitution because now what I'm going to do is I'm going to take what I have for y and I'm going to substitute that in for y in the other equation. So I'm going to take this 12 plus 4x and I'm going to put it in for y into the other equation. I'm substituting it in. 7x minus 6 times y, but now I know that y is equal to 12 plus 4x, so I'm substituting that in, and that's equal to 13. So I put it into this equation. Now if you look here, all I have are x's in this, so now I can solve for x. I'll distribute. So negative 72 minus 24x equals 13. We've got like terms. We got a 7x and a negative 24x. which is negative 17x minus 72 equals 13. We'll add 72 to both sides. Negative 17x equals 85. And dividing both sides by negative 17, you get x equals negative 5. We also have to find y, because again we're solving for a point that's going to make both the equations true. So we're going to take this one, we can plug it into this equation, or this equation. And this last one is the best one and the easiest because it's already solved for y. So let's come back up to the top here. Y equals 12 plus 4x. This equation here, but we just found that x is equal to 5. And we get y is 12 plus 20, so y is 32. We should write our answer as an ordered pair. So x is 5 and y is 32. We can go back and we could check that, plugging into each of these. And I think we have a problem. Okay, this was supposed to be a negative 5. I think I said negative 5, but I didn't put negative 5. So coming back up here, this should have been a negative 5, which would have made this a negative 20, which our answer should have been negative 8. And so our answer is negative 5, negative 8. And that seems to work out much better. So negative 5, negative 8. Again, so we're going on to number 22. We're doing substitution. We use substitution if we have a coefficient of 1 is the best way, and that one has a coefficient of 1. So what we're going to do is we're going to take that equation and solve for x. Solve for the one that has a coefficient of 1. So we would subtract 7y. We get x equals 21 minus 7y. And again, what we're going to do is we're going to take that and substitute it into the other equation for, in this case, we're putting in for x because we solved for x. So we can put it in for x. So negative 2 and x, but x is 21 minus 7y plus 7y equals 0. So putting it into that second equation will distribute. So negative 42 plus 14y plus 7y equals 0. We have some like terms. This is plus 21y equals 0. We'll add 42 to both sides. We get 21y equals 42. Dividing both sides by 21, we get y equals 2. Now once again, what we can do, we have that y equals 2. Sorry, I'm working a little bit backwards here. I'm going to come to the left. We're going to take our equation that we solved for, this one right here, and put y in. So we knew y was equal to 2, so we put y in for 2, 2 in for y. 21 minus 14, we get x equals 7. And so our solution we put as an ordered pair 7, 2. And we could check that equation by plugging 7, 2 back into our two originals. And it works.